Alright guys, we're stepping it up a notch on example 3. So this one, although it is the Pythagorean theorem, is slightly different than your previous two example problems. Okay, so first of all, looking at this triangle, okay, this is a special kind of right triangle. What do these nifty markings on my triangle mean? You're correct, you guys. It does mean that they're congruent. And what kind of triangle has at least two sides that are congruent? It is an isosceles triangle. So this is an isosceles right triangle, which means it has two congruent sides. So if this side is x, what do you guys think this side would be if these are congruent sides? Holy moly, it is also going to be x. Guys, so although we didn't know what this side is, we do know based on the markings that if this is x, this one also has to be x because they're congruent. Okay, so now that I kind of have a grasp on what my sides are, I can now successfully solve for x, which is what the problem is asking. So the first thing we have to do in Pythagorean theorem is identify the two legs of my nifty right triangle, which the two legs form the side of the right angle, which is these two sides right here. Okay, so sides A and B are my two sides that contain an x on it. So we have side A and side B. And remember, you guys, it doesn't matter which one you assign as side A and B. As long as they're the legs of the triangle, it does not matter. Alright, and remember the C value is the hypotenuse, which is the side across from my 90-degree angle. Alright, which is this side right here. Okay, so side that is the length of 10 is my side C. Alright guys, and from here we can set this bad boy up and solve this thing for x. Let's do it. So we're going to have our a squared plus our b squared, which in this case is x squared plus x squared. So we're going to have x squared plus x squared equals my c squared, which my c is a 10. Yay! 10 squared. Alright guys, let's start solving this thing for x. So x squared plus x squared, both of these secretly have a 1 in front. And when we combine these two like terms, 1 plus 1 is 2. And remember, the x squared you leave alone. You do not touch it. So it's 2x squared will equal 10 squared. So 10 times 10 is 100. Alright guys, let's start solving this thing for x. So the 2 is secretly multiplying to the x, so the way we bring it to the other side is by dividing both sides by 2. And 2 divided by 2 cancels and turns to 1, so we're left with x squared equals 100 divided by 2, which is 50. Alright guys, the last thing, we're so close to solving for x, but currently we have an x squared, not an x. So how do we undo an x squared? You guys are so smart, you do square root both sides of the equation. And a square root will undo the squared, so we're left with x equals the square root of 50. I remember we don't put the plus or minus because we cannot have a negative side length on our triangle. Now before I box in my answer, square root of 50 is not a perfect square. So what do we have to do when our radicals are not perfect squares? You guys are so smart. You do have to do a factor tree. So I'm going to do my nifty factor tree over here and write down what goes into 50. Okay, so two things that multiply to be 50 are 5 times 10. And two things that multiply to be 10 are 5 and 2. So now I have to determine what stays outside of my square root and what goes on the inside of the square root. And we do that by finding our cute little couples at the ends of the branches. So, do you spot any cute little pairs at the ends of the branches in my factor tree? I spot one right here. We got a cute little couple of 5s right here. Okay, so the 5s are going to hop outside my square root. And the lonely single number at the end of the branch, my lonely 2, stays inside the square root. And that, you guys, would be my final answer. So the value of x is 5 root 2. So both of these sides are going to be 5 root 2, which is awesome. So this is 5 root 2 and this one. Oh man, that one wasn't too bad. Once we got past this part, it really wasn't too bad of a problem. And it was actually a fan-double-tastic problem, if I do say so myself. Alright guys, well that's it for Pythagorean Theorem. I hope you're ready for something new.